I'm Ray Loy. I work in the performance engineering group at ALCF, and I'm going to give you a very quick, the most important things to know to start up and get running on things, and it's mostly focusing on the Blue Gene queue, but I'll mention a few other things as well. I think that most of you, some of you, have read some documentation that covers this to do the pre-class assignment. So I might go a little bit faster, but feel free to interrupt me if you have any questions. And at the end, I'm going to invite you to talk about any issues that you did have with that assignment, because we have plenty of time to address that. These slides, or I should say a slightly, a 2 hour ago version of these slides is actually online on the machines for reference, and we'll be posting it on the ATPESC agenda page as soon as possible as well. And I'll just in advance point you to the online user documentation for ALCF. So I hope that most of you have logged in at least once with your Cryptocard prior to this moment, but I thought I would give you some tips about it in general, because the process from the outside is a bit opaque for security reasons. Not very much information is given when you fail to log in, because they don't want attackers to be able to know what's going on exactly. But what I would suggest is that when you log in, right, you're prompted and you need to type in your PIN and the value shown in your Cryptocard. If that fails the first time, my recommendation would be to try typing. Don't push the button and generate a new code. Just try typing it again, because the odds are at least even that you may have just mistyped it. And the string is not, right, this is the number that you're given from the crypto token is in a pseudo-random sequence. And the other end doesn't know to advance the window of what's accepted until you actually succeed, right? So if you failed, the window's still in the same place, and you can try typing it again. It has no negative effect other than potentially being a failed login. The reason to not just immediately generate a new one is that if you generate too many new ones, you get ahead of the server, because it only updates the window when you succeed. And so it's worth a second try. And then suppose your second try fails. What I'd recommend is to try a different ALCF machine, just on the basis that there may be something going on with that particular host. So suppose you tried to connect to Vesta and you tried twice and it didn't work. You might want to try, let's say, Mira instead, because if the problem was just something going on Vesta at the moment, and you successfully log into Mira, it will reset your count of the number of failed logins, right? Which is good, because then you won't get locked out, right? When you exceed some unknown, unpublished number of failed logins, you get locked out for a while. So, and then the next step up, if there are too many failures, and this isn't necessarily due to you as one person, but if too many login attempts from a single IP, so for example, this room is probably all coming from one IP. If too many failed logins come from one IP, then the IP will be blacklisted, and the way you can tell that happens is you won't be able to reach the Argonne site at all, not even the website. So if you see that you can't reach the Argonne website, it's pretty sure that you won't be able to log in either. Okay, so after you log in, you will have to make sure that you have at least a basic environment, shell environment, to get done what you need to do. And if you've used any clusters at other sites, have accounts at other sites, you may have used a package called modules. And if you have, then what I will just say is this is very similar, but there are some small differences. If you haven't, that's not important. The thing to know, though, is that there's a file in your home directory called .soft, and it contains some keys and macros. And by default, it may only have the macro default in it. And what that does is when you log in, it's set up as part of the system that it reads the keys and macros in this file, and it makes corresponding settings to your shell environment, and then before it gives you the prompt. So what you might need to do is to add a key, as in this example, to add a key that selects which compiler do you want to use. I think on the next slide there will be the keys for the other compilers. And the other thing I'll just note is that the Blue Gene systems use .soft, and because the non-Blue Gene system, Cooley, shares the same file system with Mira and Cetus, it can't use the same file, so it's named Soft Cooley there. And when you make changes to this file, you need to refresh your environment by typing resoft, or alternatively, you could log out and back in again. So, next step, choosing compilers. This is what you do if you want the IBM compilers. You use this key, the one that was on the last slide, MPI Wrapper XL. The IBM compilers, if you've never used them, I'll just mention that they have different entry points. It's really all the same compiler, at least the C and the Fortran compilers are two distinct compilers, but it implies something if you run it using just MPI XLC is a wrapper that it tells it that this is C and not C++, and CXX tells it that it's a C++, and so on for the other versions. And another IBM-ism, if you're not familiar with XL, is that you need to use variants of the compilers that have an _R tacked on the end if you want to build thread-safe code. So that's, if you want to use GNU, we have the same kind of situation with different wrappers for different flavors, C, C++, Fortran 77, Fortran 90, and with you get that by using MPI Wrapper GCC, and we also have the Clang compilers with MPI Wrapper BG Clang. So what is the simplest Blue Gene Q job script? Well, here it is. It's really 2 lines. It's some Cobalt options. These are actually options that you could have typed on the Q sub line, but they're here. They'll be pulled out of here. It's easier than typing them every time you submit the job. And run job is the IBM equivalent of MPI run or MPI exec. Okay, so this job script, when you submit it, I'll show an example on the next page of submitting it. When it starts running, Blue Gene doesn't actually have the compute nodes can't run a script, right? The compute node environment is very special. It only runs one program. It can't fork and things like that. We'll talk much more about this later. But this job script actually runs on a login node when your job comes up. And this run job will then invoke the action on the compute nodes. And so in this case, I've asked for 16 processes per node and a total of 32 ranks. One special thing to note is that this colon separates the run job arguments from your program, and its arguments would go on the end here. And this colon is a word. It's not punctuation. It's actually a word. And there needs to be a space before it and after it. So that's a common pitfall. And then also pay attention when you're reading the docs. that some things are 2 dashes and some things are 1 dash, and that's annoying and confusing, but unfortunately just the way it is. This argument it's sort of the equivalent of saying what nodes you're going to run on. This variable is set for you automatically when the job runs, and it will have the name of a partition on the blue gene, which is a set of nodes that targets where you're going to run. And of course, you're not allowed to run anywhere except where that location that is given to you. If you try to run somewhere else, it will just fail. There's a script like this in that directory that I pointed to on the first slide. So when you do get online and get a copy of these slides, it will point you to the example if you don't have one already. And in that example, there's some syntax for how to pass environment variables and ways to control the output. When you submit this job script, because I put a lot of the options in that first line, I can just say qsub job script, and it will do things. But you also, this is the equivalent of what was in there. You could type qsub this, right, and it would do all this. And I think it's much easier to just put it in the script. And you do need to make sure that the job script is executable with a chmod plus X. And if you don't specify a queue, it will go to the default queue. And for @pesc, we have some special queues set up. I'll talk about that on a following slide. And you need to specify a project here to bill the time to, right? So @pesc has a project, and it would be kind of annoying to type that every single time. So I'll just give you a handy tip that if you set the shell environment variable, cobalt proj for projects, to @pesc, then you won't have to type the -a or even put it in your job scripts, because it will pick that up from your environment and use it as the default. And so there are many other options for qsub. You can get it to email you when the job's over and stuff like that. You can check the man page for that. I've been talking about job scripts on the blue gene, but later on in this training program, not to be confused with a school, there will be some work on Cooley, which is a Linux cluster, right? So it uses the same queuing software, Cobalt, but there are some differences because it's not a blue gene machine. So I was unable to paste the example script into here because the network is down. I apologize for that. This was a last minute thought. But I'll just mention that it's different. It's actually slightly simpler. And it is documented on the online user guide. So for the moment, I'll just have to refer you to there. But it's different. You can't take a blue gene script with the run job in it. You'll have to do something just slightly different. And if you've used a Linux cluster somewhere else before, it'll be more like that than with the run job. Okay, so it's probably pretty obvious you do things like qstat, qdel, showres. Okay, so showres is how you would find out what reservations are set up. And this is important for you guys because there are some @pesc reservations set up. And if in doubt, you can see what times that these reservations are set up that give you better access to stuff. I'll come back to the whole queue and reservation thing in more detail on a later slide. There's a man page, of course, for more info. While you're running, while you're setting stuff up and trying to figure things out, you might want to run a bunch of quick short tests in succession. There is actually a way to run an interactive job. And what that means, it's very similar to the way that the PBS queuing system does it, is that you submit a job saying I for interactive. I apologize for the typeface. The Argonne style file uses a typeface with capital I's that look like ones. So that's why I made the comment here. So you say interactive, and I say I want 30, how many nodes and how long. And what that does is instead of running something, that queues a job, and we haven't told it what to run, right? So what it does is it queues a job, and when the job has resources to run, it gives you a shell prompt, and then you're ready to run something. Well, how would you run it? You would type the same commands like you would in the job script. So you would type run job, whatever. And the thing is, though, that you can continually type run job and do another one. You can edit things and do another run job, and while your Cobalt job is still active, right? So you don't have to wait to get the nodes again until this time expires. Now, there's only one thing different from submitting a normal batch job, is that when you get the shell prompt, the partition may not be quite ready to use yet. It's sort of it's something that we should be able to take care of automatically, but we're not able to right now. So you need to just type this command when you get the shell, wait boot. And wait boot will tell you, just hold on a second, let me check, and when it says, okay, you're ready to go, then you're ready to go. A question?
Is the file system commenting such that if you do an edit in an interactive job, it'll write that edit back to the main terminal?
Yes, right. There's no difference. The shell you get in the interactive job is running on a login node, just like the shell that you launched the QSub from, and it accesses the same GPFS file system. And right, there's no propagation issues. So you can run an editor in the interactive job shell. That's fine. So what happens when your time runs out? So when your time runs out, the shell doesn't actually get killed because you would lose an editor or something like that. So we decided it would be a little more friendly not to kill the shell. However, you lose the ability to launch run jobs because you no longer have the reserved nodes that back it up. So if you have doubts about, unfortunately you don't get a warning message that this happens, but you can check QStat. If you check QStat, and this is set in your interactive shell, this will be set for you. You could just say QStat that to see if your interactive job is still alive. And if not, then you should probably just clean up your editing sessions or whatever and exit the shell, because it is now just a non-privileged shell that you can't run things from. This slide summarizes the queues and the special queues and reservations that are available for this class. So there are actually 3 Blue Gene machines at ALCF. The one that this class will primarily use is the 4-rack system called Vesta. So you can submit to the queue at PESC 2015, and for most of the time, there aren't actually reserved nodes that are assigned for the class, but your jobs will get priority over normal users' jobs in the system. Now, during certain periods of hands-on sessions, there will be actually set aside exclusively nodes, and you don't have to do anything differently. It's just that at different times, submitting to that queue will give give you either raised priority or raised priority and reserved. So if you want to know what times they are, just check show res. And the output to show res, by the way, will use GMT because the system uses GMT. But if you set the time zone variable in your shell environment to US Central, then you will see it in the local time. So now the ATPESC 2015 queue will only have access to either at least 512 nodes or a larger set during the reservation. Now, if you need to run anything, right, the machine is 4 racks though, that's 4K nodes. If you need more than the 512 nodes, go ahead and run in the default queue. There's no problem with that. It's just that you don't have a special privilege to do it. In terms of priority over other jobs. But the system doesn't tend to be super busy usually, so that shouldn't be a problem. If things are not working out, come talk to us, and we'll let you know. Now, if you are doing really great on Vesta, and your code works on some small cases and whatnot, and you'd like to run bigger, you can use the big machine, Mira, the 48 rack machine. Now, Mira is on a different file system than Vesta. So you would have to move your files over, right? You'll see when you log in, it's a different home system. But Mira shares its file system with another small blue gene, Cetus, that's 2 racks, as well as Cooley, the x86 cluster. Okay, so it's sort of this division, as Vesta is on one file system, Mira, Cetus, Cooley is on the other. And in a way, Cetus is the debug queue for Mira. It's a different host, it's a different machine on the same file system, but if you move your code over from Vesta, you might be pretty confident that it works, but if you have any little tests to run at small size, like because you've moved the files and maybe you needed to change something, and you want to run a quick turnaround small test on the same set of program files, you can run that on Cetus. However, we don't have any particular reservations or queues on Cetus. You're submitting to the default queue like a normal user. But when you need to run the big job on Mira, there is also a queue called ATPESC 2015 there. And every night for the whole duration of ATPESC, we have set up access to 8K nodes and between 7 and 10 p.m. And if there's something bigger or longer than you find that you can submit to there, that you would submit it to the default queue and then talk to us about getting its priority raised by a sysadmin. So, and we'll be happy to take care of that. So later on in the course, when some usage of Cooley, the Linux cluster, comes up, there are some hands-on related reservations that were set up, and they have different queue names than ATPESC 2015. So as I understand just from looking at the names, one of them is for the OpenMP session, and the other 2 are for the visualization session. And the session leader for that will tell you more. I'm sure they'll remind you of what to do. But outside of those sessions, you would just use the default queue. Okay, I think I have probably covered most of these items already in talking on the previous slide. Vesta as your main resource. So the longest you can run on Vesta is 1 hour. And if you start queuing a lot of things, the limit on how much things you can submit at most 10 jobs, and at most 2 of them will be allowed to run at once, just to try to be fair to everyone. And but you also can't queue up more than 1024 node hours worth of jobs. So in other words, if you submit a 1 hour job on 512 nodes, you can submit a second one, but not a third one. It just won't let you. It's not that only 2 will run. The third one won't be queued because the first 2 total 1024 cores for 1 hour. So it's just to help even out usage among the whole group of people. And that's the same limits that apply in our normal default queue as well. One thing to note is that the small jobs and small tests are best run on Vesta, right, the primary machine, because Vesta has a smaller hardware partition size than the other machines. So if you're not actually using, if you run a 1-node job on Vesta, you'll have to be allocated 32 nodes. That's the smallest chunk that can be allocated. And because you have to be allocated that, you'll be charged for that time as well, and you also prevent other jobs from using it. Remember I said that when you move to Mira, you might need to run some small tests with the code in situ. But just bear in mind that small tests on Cetus use a minimum of 128 nodes versus the 32 on Vesta. So that the chunk size is bigger, and you should just be aware of that. So it's there if you need it, but use appropriately. Someone, I think, was probably bound to ask about what's the deal with NERSC and OLCF, because you have been offered accounts there. NERSC, both of them will use their regular queues. You can submit to their regular queues, as I understand it. And Hopper will, one of the hands-on sessions, I don't know which one, will have a reservation set up to use, and I'm sure that the session leader of that part will let you know what the name of it is. I mentioned just a moment ago that the smallest jobs you could run on Vesta was 32 and Cetus 128, and Mira is in fact 512, the largest of them, and because Mira is the largest system, it's geared, it's both wired and geared to do big jobs. So if you ask for 1 node on Mira, you're going to be using 512 nodes because it's not possible to do anything. And when you do submit that run job, remember I mentioned that -p argument specified how many MPI ranks in each node, right? A node has 16 cores, but you can set the number of MPI ranks on there to all kinds of values from 1 to 64. So at 1 rank per node, you actually have available in that 1 rank 16 cores totaling 64 threads. So why would you want that? If it's OpenMP or P threads, then you would have access to all of those because they have the node is the domain of shared memory. So the sort of the standard way you probably might want to run is 16 ranks per node, which gives 1 core per MPI rank. So how does it work when you ask for 32 ranks when there are only 16 cores? So it actually implements it silently under the covers by making different threads for the 2 MPI ranks and just assigning them different parts of partitioning the node memory in half and giving a different thread to each MPI rank. You don't have to worry about it is actually threaded, but in that case you don't need to worry about it because, right, the basic problem with threads is that when they stomp on each other's memory, but if they're all both using completely disjoint parts of the node memory, then there's nothing to stomp. So speaking about OpenMP, I already mentioned, but I'll remind you that with the XL compilers, you need the _R versions of the compilers, and you need to enable processing of that with the QSMP equals OMP option. And I should note that with the XL compilers, SMP doesn't just mean OpenMP. It implies some other automatic SIMDization techniques. And if you don't want them to happen automatically, you might want to select the sub-option called No Auto. And another thing related to this is that the way, when you turn on this general SMP option, it relies on some internal compiler functionality to identify the loops where threading could happen. And that implies that it goes through some of the earlier stages of optimization, even if you selected -00. So if you're debugging and you say -00, but you also turn on OpenMP, you will not in fact get 00 in the loops, in the OMP loops. And so you can, however, fix that by adding no-opt as like a third option here. So I just want to mention that in case you next week in the debugger session when I start talking about debugging with you guys, that you start debugging something and it starts skipping around in the loop because the code's been reordered, and that's why. So we'll remind you. The probably number one thing besides the _R is that about threaded code is that you set, as you would expect, you set the number of threads with OMP num threads, but the thread stack size is set with this environment variable, and I don't recall the default, but it's not terribly big. And if you overflow the thread stacks, it will just silently do crazy things. So the first thing to check when you have a threaded program and it's misbehaving is to try increasing the stack size. And if it does something different, that might be related. So, and here's an example of how you would insert the environment variable into the run jobs environment here. Okay, so that ends the formal information that I had, and I know you've asked some questions already, but in your own experiences with the assignment or anything, I'd be happy to elaborate on anything you had trouble with. Did anyone have problems submitting jobs or want to know how to do something that there was one question on the list right before class. Someone had asked, with the Excel compilers, how do you do the equivalent of like -d foo equals 5? Now the Excel compilers don't take that option directly, and when we get back online, I responded to that pointing to the right incantation to make it work. Just off the top of my head, I think it's something like, there's a generic option that tells the Excel compiler to pass the sub-option to the preprocessor of the compile phase. And it's something like -F, W, F, comma, something equals -D, whatever. So the -D argument's in there, but you have to prefix it with something to tell it to insert it into the process, because I'm not sure why, but the IBM guys didn't want to embrace using -D like the rest of the universe. But anyway, that was one question that already came up. Does anyone else have?
This is not a problem, but I wonder if soft has the equivalent of module avail, so I could find.
Yes, it does. No, and this is exactly the kind of the questions are about anything that we've talked about. So if you just type with no options softenv at your shell, then softenv, SOFTENV, then it will list the whole catalog of the keys and macros that are available. So you could see the different version numbers, and typically for any given thing, there might be a generic key that's the most recent, and there might be individual keys for previous versions if you're trying to, rule out what, some update has caused a problem or something like that. So what's not so easy to do is to clear your environment and start it from scratch, or changing things on the fly is a little bit tricky, because you need to do this resoft command, and resoft is actually a shell alias, because you can't change. A normal command runs in a different process. If you change the environment there, it doesn't come back to the parent. So anyway.
Is there an equivalent to module purge?
No. Is there an equivalent to module purge? So to clear all modules? No. The closest you could get is if you change that's the thing. The sort of interactive commands are limited pretty much to either add a key or macro, so that's soft space add, and then the name of the key that you want to add, or resoft, which is reread the .soft file. So a purge would essentially be set your .soft file to be at default, which would be empty, right? Or just the default set, and then do a resoft.
So if you do clean everything out of your soft file and do a resoft, it won't leave your previous packet modules or whatever you call them hanging. It'll actually just get rid of them.
That should be the case. Yes. I know I'm hedging, but I found with SoftEnd that you should try it and make sure that. Now, I'm 99.99% sure that that's the case, because that will, in fact, when you do that, you will lose any environment that your own, like bash RC set, because the process at login was to run the soft stuff and then to source your bash RC. And when you resoft with like an empty .soft file, I know that it drops those other things. So I'm pretty sure it drops everything other than what was in it in the first place. Mm-hmm.
You mentioned Vesta takes 32 nodes as a minimum.
Yes, Vesta 32 nodes.
And each node is 16 cores?
Mm-hmm.
That's like found at one core?
Yep. This is large-scale computing. Right? If you need, so of course for tests we run one node, one core problems all the time. It's just that that's the smallest you can allocate. It's that set is defined in the system and connected to I/O nodes. There are architectural issues that the Blue Gene, we'll talk in much more detail about this in tomorrow afternoon. Scott Parker is talking, unless he's not available, in which case I will. He'll explain the topology of the machine. And to make a long story short, right, the nodes sit in a 5D torus, and the nodes that you're allocated need to be a rectangularly contiguous patch in that torus, and that the wraparound for those partitions can only happen where there are wires to do it. And so between that constraint and the way that the compute nodes are connected to particular I/O nodes, which facilitate the whole process of starting up the job and so forth, that there are these fixed limits. Yeah.
And you mentioned Mira as between 8 and 10 p.m.
7 and I think 7 and 10.
What happens after 10?
We just don't have the reserved nodes. You can still put.
The code is running, it just keeps going?
When there's a reservation for a particular set of nodes, it's for a time period, so 7 to 10. That means that at 9 p.m., if you submit a job that's more than 60 minutes, it will stay queued, it won't run. So, so if you see, so the two reasons it wouldn't run are there are not enough nodes empty at the moment to run, or there's not enough time left in the reservation to run. When you're in the regular queue, there can be, this somewhat applies here as well, because are you familiar with the general concept of backfilling in queues? So if you have, let's say we have this bunch of nodes and this bunch of nodes, and we could run something here or on the whole set, right? And so let's say that this bunch is running something for an hour. It has an hour to go. And there's a big job that could run, and that could run after that one is finished, right? So on the other one that's empty, the little one, you wouldn't really want to run something more than 1 hour because it would delay the big one that's waiting. But let's assume the big one has been waiting longer, right? So in that case, you would set the backfill window to the length of the other one, saying we won't run anything in this slot because we're planning to run the big one. So that kind of thing can happen.
Why is the machine connected to the 5G Taurus?
It's a scalable way to connect a very large number of nodes together. It has an incredible amount of bandwidth. And it's one of the things that makes the Blue Gene special. In fact, the next generation machines are in a way having, there are many trade-offs, and it has a lot to do with market and the manufacturer, road plans, and so forth. But the next generation machines actually have somewhat less specialized networks.
You mentioned that you get no cross-traffic.
Right. Each one novel thing about it is that because they're contiguous patches, the message traffic among the nodes in your job is not competing with any other job in the system to talk to each other. And that's a very nice property. It makes your runtimes not only fast, but also very repeatable. Because the only time that external influence applies to your computation is when you go to I/O, which is something I think you expect, right? Because file systems by nature are shared. So. Mm-hmm.
So Ray, are you saying that that feature of sort of network isolation will not be true for Theta and Aurora?
That's correct. There is some talk about circumstances of possibly adding it, but it as part of the basic design, no, it's not. They use they do not use a torus network. Yeah. Mm-hmm.
And if your minimum required nodes is 32, would you have to request in multiples of 32, or could you run 33?
You can, if you ask for 33, you'll get 64. Because there is no way to satisfy 34 other than by giving you 64. So it's just the thing that you need to be, and in this context, it's not terribly important unless you're running large jobs. But we have, if you are a real researcher and you have a certain allocation for your project, you need to make sure you're not squandering what you've been allocated, right? So, but one node versus 32 is, it's the question of if you run 16,384 versus 16,385, right? Because that all of a sudden you're doubling a much larger number, right?
Does that mean that Argonne's codes only run on power of 2 number of ranks and
Well,
multiples of 32?
I mean, For the most part, the powers of 32 are the defined partition sizes, and those are the most efficient ways to run. So not all codes do that. There are a few other sizes in between. So the sizes on Mira are, from one, in Ks, 1, 2, 4, 8. There's 12, which is not a power of 2. 16, 24, right, which is double of the 12. Then 32, 32, and then 48.
But out of curiosity, if one of the Argonne specialized codes would be put on a Cray and one would request 50 nodes, will it fail? With a high likelihood. Is it an inherent optimization target?
Well, I don't think that the number of ranks that you were running on would particularly be a reason for it to fail, right? I think that the flexibility, the main issue on the Blue Gene is that you might be wasting nodes that you allocated, not so much whether it would run or not, and then going in the other direction, whatever count you wanted for Mira, it's more flexible on the other systems how many nodes you get. So, but I don't think that's a pass or fail issue, and other more machine-specific optimizations are possible, and then they just might not be applicable. So
Right. Typically, what people see on if they move from Mira to say Titan is that if they have a very tightly coupled calculation and they're used to the regularity because of the internal network not being shared, they find that their runtimes are more erratic and often substantially longer, because on those systems you can get just a single node here and a single node there. You communicate between those two and there's a lot of cross traffic, but it doesn't stop it from running. The performance will be very different.